Today we're going to take a look at starting integration by parts. This process is going to be something that we use when we need to find the antiderivative of a product, and U substitution is not going to be helpful. So there's a special formula that you need to know. It says if you have the antiderivative of a product, U dV, that's going to be equal to UV minus another integral of V du. Which doesn't seem to make much sense, but after we go through the first example, you'll see how it works. The first thing that we need to talk about is how to choose something for U. So there's an acronym that we're going to use, and that's LATE. L stands for logarithm. If you see a logarithm inside the antiderivative, inside the integral, then you want the log to be your U, because we're going to eventually find the derivative of the U thing, and we know how to find the derivative of a log, but not the antiderivative of a log. The A stands for an algebraic term, something that you would be able to use the power rule on. Okay? The next is something trigonometric. And the last one is something exponential, like e to the x. Alright? So your first choice is something logarithmic. Your second choice would be something algebraic, something that you could do the power rule with. And then trigonometric and exponential, e to the x. For our first example, we're going to look at x e to the x dx. And we want to find the antiderivative of this. So the first thing we need to do is choose U. So if we go through that list of LATE, L is logarithmic, there's no log here. A is algebraic. There's an algebraic term right here, plain old x. So we're going to have U be equal to x. Therefore, du, the derivative of that, would be 1 dx. So du is just equal to dx. The part that's left over, e to the x dx, that's going to be our dv. And what we need to do is figure out, well, what's v? What's the antiderivative of this? And if we think back to previous lessons, the antiderivative of e to the x is itself. There's no need to write a plus c here. The plus c will come in at the very end of the problem. So, we're ready to start plugging things into the formula. So, the antiderivative of x e to the x dx is equal to u, which is x, v e to the x, minus another integral, v e to the x du dx. So I'm just following that formula from the previous slide. So the first part, x e to the x, now I don't have to do anything with that. But now what I need to do is find the antiderivative of this guy right here. Now what did we say the antiderivative of e to the x was? We said that was just e to the x. So now our antiderivative, we keep the x e to the x from before, we subtract this. Since there's no more integrals left over, we have our final answer, which means I need a plus c at the end. So this in red is the antiderivative of x e to the x. Now we could check it using derivatives and the product rule, but if we go through and do that, you're going to see that we're going to end up with x e to the x, the original integrand. Problem number 2. Again, we want to start by picking out a u and therefore a dv as well. So go through the list. LATE. L, logarithm. I see a logarithm here, so I'm going to do u equals ln x. The derivative of that is 1 over x dx. And now I need my dv. dv is whatever's left over from the original integrand. So it's x squared dx. Oopsies. Writing that out of order. X squared dx. And to get v, I need to find the antiderivative of dv. Antiderivative of x squared is 1/3 x cubed. And now that I have these four pieces, I'm ready to put them together into the formula. So the formula says the antiderivative of x squared ln x dx is equal to uv. So u is ln x times v, 1/3 x cubed, minus the integral of v du, 1/3 x cubed times 1/x dx. Which looks like a much bigger mess than it's worth, but we're actually really close to having an answer. For starters, this first term, I'm going to just put the 1/3 and the x cubed first. So 1/3 x cubed ln x minus. Now on the second one, that 1/3, I'm going to pull it out in front of the integral. So now this is gone. And I'm left with x cubed times 1/x. Well, that's just x squared dx. And I can find the antiderivative of this using the power rule. So I'm going to have the minus 1/3 times the antiderivative of x squared, which is 1/3 x cubed. We're going to tack on our plus c at the end, and the first part stays the same. So to get my final answer, all I need to do is combine the two 1/3s in the second term. So my final answer here is going to be 1/3 x cubed ln x minus 1/9 x cubed plus c. And again, I could check my answer by finding the derivative, which would require the product rule, which is why we're not going to bother doing it out. All right, 2 down, 2 to go. We need to find the antiderivative of x squared sine x. So choose u. So LATE again. L, there's no logarithm. A, algebraic. There's an algebraic term right here. So u is going to be equal to x squared. So what would du be? The derivative of x squared is 2x dx. Okay. That leaves me with what's dv? dv is what's left over here. Sine x dx. So now I need to know the antiderivative of sine x dx. The antiderivative of sine is negative cosine. And now we're ready to start our formula. So we have the antiderivative of x squared sine x dx is equal to uv x squared times negative cosine x plus, I'm sorry, not plus, minus the antiderivative of v du, negative cosine x times 2x dx. So some of you are probably already realizing why I said plus before. And that's because I'm going to have a double negative in the middle here, so that's going to become plus the integral of the positive instead. So if I just clean this up a little bit, I'm going to have negative x squared cosine x plus the integral of 2x cosine x dx. All right, so that's the first step. Now here's the problem. If I look at this integral that I have at the end here, I still have a product where u substitution won't help, so I need to do integration by parts again. So now we need a new u and a new dv. So I'll go through the list again. L, logarithmic, nothing there. A, algebraic, that would be the 2x. So du is now going to be 2dx. dv is the remaining part, cosine x dx. So then v is the antiderivative of that, which is sine x. And now I need to start doing this out again. So if I focus on just this information, I'll write this part in red. So the antiderivative of 2x cosine x dx will be equal to uv 2x times sine x minus an integral of v du 2 sine x dx. Which, yes, there's still another integral, but I can easily find the antiderivative of 2 sine x because the 2 can go out in front. This part here takes the place of this integral here. Okay? So, here's what we're going to end up with. So we replace the integral for the first integral with what I have written in red. And now I need to just find the antiderivative of this guy here. Well, the antiderivative of sine is negative cosine. So I'm going to have negative 2 cosine of x. And we're going to tack on our plus c. But there was a negative here, so the two negatives cancel, become a plus. And then if I backtrack, my final answer is going to come out to this. We're going to get negative x squared cosine x plus 2x sine x plus 2 cosine x plus c. So that one was particularly long because I had to do integration by parts twice in one problem. Alright, we have one left. This one we're only going to have to do integration by parts once. So for example 4, we're going to find the antiderivative of 4x cosine 2x dx. So again, we need to start off by choosing u. There's no logarithm. A comes next, and that's algebraic. Algebraic is 4x, so we do u equals 4x. du is therefore just 4 dx. Next up, we need to choose dv. And again, that's what's left over. Cosine of 2x dx. And I need the antiderivative of that to get v. Now here's what you need to watch out for. There's a 2x here, which implies that we technically should be doing u substitution with this. Some of you are going to remember that it's directly related to the chain rule. The antiderivative of cosine is sine. The inside must stay the same. But I need to compensate for it out in front. So we're going to end up with a 1/2 here. Now let's just check by doing a derivative. The derivative of this will be 1/2 times the cosine of 2x times the derivative of 2x, which is 2. The 1/2 and the 2 disappear, and we get back to cosine 2x. And of course, there will be a dx at the end. I just ran out of room. All right. So we're ready to start writing out our formula. So the antiderivative of 4x cosine of 2x dx is equal to u 4x v 1/2 sine 2x minus the integral of v 1/2 sine 2x du 4dx. Okay, so let's clean up anything that we can. So what we really have here is 4x times 1/2 out in front. That's 2x. And then we have sine 2x. Minus integral. And now we've got a 4 and a 1/2 to give me a 2 sine 2x and a dx. So now I need to find the antiderivative of 2 sine 2x. If you think of it in terms of u substitution, this is what I did not write out when I was doing the antiderivative of cosine 2x. If I look here and just do u equals the inside 2x, du would equal 2dx. And I actually have a 2 and a dx. When we were doing it up top, we didn't have the 2 and the dx, we just had 1 dx. So that's where the 1/2 came from. So this is like having the antiderivative of sine u du. And the antiderivative of sine is just negative cosine. It would be negative cosine of u, but the u we know was 2x. We tack on the plus c at the end because this is our final antiderivative. And that was a negative. There was a minus out in front. The double negative makes this a plus. That's coming from this minus sign combined with the minus sign we just had. So we're going to have our 2x sine 2x back out in front plus cosine 2x plus c, and that is our antiderivative. Final answer. All right. I hope that these problems help you to get ready for your homework tonight. If you have any questions, please stop in to see me to go over. Thanks.